Problem number 9. So I've been given this function here, y equals 2 sine 2x. And the first thing I want to do is I want to graph it in the calculator in the z-trig window. I am in radian mode, which is where I want to be for graphing. I'll go to the y equals area and put it in 2 sine 2x. Let me close the parentheses. And I'll go to zoom and choice 7. Remember, the z-trig window is the one that counts by pi over 2's. It's a little bit hard to tell here, but the tick marks are being covered up. Here's pi over 2, pi, 3 pi over 2, 2 pi. I guess this would be 5 pi over 2. The y marks are by 1, so 1, 2, 3, 4. Okay, now that we have that, the goal is to write other equations that will generate this same picture, but that use a different base function. So in letter A, for example, we want to use the regular cosine function. Before we get there, I should probably jot down some of the key features of this graph that we can use for all three examples here. How about the amplitude of this function? Well, I think you can see that the midline is right here along the x-axis. The high spot is at 2, the low spot is at -2, so obviously the amplitude is just 2. The period, well, let's see, if I start here, how far will I go to get one cycle in? It looks like it ends right here. That would be the second tick mark. Remember, those tick marks are kind of covered up, so pi over 2 and then pi, so the period would be pi. And the midline, we said it was the x-axis, which has the equation y equals 0. So all of that's going to remain the same. What's going to change each time is the phase shift that I'm going to need to use depending on which base function I'm working with. So letter A wants the regular cosine function. That's the vase. I need to find myself a vase. I can see one here. Starts at the high and ends with the high. If I want to use the regular cosine function, I need to know what this spot is. Now this is not a tick mark spot, but it is half of the first tick mark spot. The first tick mark was pi over 2, that first one that's covered up. If you cut that in half, you're going to get pi over 4. So I feel pretty confident that if I want to use the vase picture, the regular cosine, I'm going to need to have a phase shift of pi over 4 to the right. Well, if I put all this together, I can write down my equation. It would be y equals, the amplitude is 2, so the A would be 2. We're using regular cosine. And then the B number, well, I have a little formula for that, right? B equals 2 pi over the period. The period is pi, and so the B is 2. And then open up a parentheses for x minus the c. The c would be pi over 4. It's pi over 4 to the right. X minus pi over 4. I don't have a plus d on the end because the midline is just at 0. So what we're saying here is this equation should make the same picture. Let's test that out in the calculator. I'll go back to my y equals. I'll go to the red line and type in what we came up with. Make sure to enter in all those parentheses correctly. Okay, I think I've got it in. Let's see if it's the same picture. Sure enough, exactly the same thing. Okay, let's try letter B. So now I'm not looking for the vase. I'm looking for the valley and the hill. I want to do a reflected sine function. The amplitude, the period, the midline, all that stuff is going to carry through. It's really just going to be the phase shift that's going to change. So let's see here. Where is a valley and hill I could use? I see one right here. There are many that I could use. The one that I first noticed was this one. And all I really need to know is this spot. It's the first tick mark spot, which is pi over 2. So I think if I just use a phase shift of pi over 2 to the right, then I will have the equation. I can write it down now. I'm going to have a negative because of the reflection. Amplitude is 2. We're using sine. The b will still be 2. And my phase shift is now pi over 2 to the right. So x minus pi over 2. Again, let's try that one in the calculator. I'll come down here and I'll replace this with -2 sine 2 parentheses. In fact, I think I can just insert that in. And then x minus pi over 2 we had. Okay, I think I've got it in there. Hit the graph. Sure enough, another equation that makes exactly the same graph. And then letter C, we want to use a reflected cosine, so I need to find a ghost somewhere in this picture. Again, there are multiple. Here's one that I see pretty close to the y-axis from one low point to another. Let's see. This time I'll have to shift to the left to match this particular ghost. It's halfway again to that first tick mark, so it must be another pi over 4, except it'll be negative pi over 4 there. My phase shift then is pi over 4 to the left, which means my equation is going to be pretty similar to that first one that we did. I'm going to have a negative for the reflection. All the other information stays the same, and then in here I'll have a plus pi over 4, since my C value is negative pi over 4. Again, we can check it on the calculator. Y equals -2. We have cosine now, and then 2 times x plus pi over 4. And we'll hit graph, and once again, it's exactly the same. We have found 3 alternate equations that all generate that same initial graph. Problem number 10. I have a set of numbers being described in each case. I want to write the first 5 numbers. In part A, I have the set of numbers x equals 1 plus 2k. What's k? K is an integer greater than or equal to -2. In other words, the first k is -2. And then the next k after that would be -1, and then 0, 1, and then 2. Those would be the first 5 k's. To find the first 5 x values, I would just have to plug each k into the little formula we were provided. Remember, x is 1 plus 2 times that particular k. That's 1 plus -4, which comes out to be -3. And just repeat that process. 1 plus 2 times -1, that's 1 plus -2, which is -1. If you plug in 0, you're going to get 1 plus 0, which is 1. You may start to notice a pattern. I'm noticing that these values are just going up by 2. I'll check that one more time. Now I'm plugging in 1. Yeah, sure enough, this is 3. So I don't even think I need to finish the chart there. It's obvious it's going to be -3, -1, 1, 3, and then the last one must be 5. The numbers are going up by 2. Letter B, similar idea. Let's see. Now the first k is -1, and then we go up from there. So first I'll plug in k equals -1. We can probably do some of this in our head. The x would be 1/2 plus 4 times -1. So that's 1/2 plus -4, or -4. Let's see, we're being asked to work in terms of fractions, so I guess I should get a common denominator here. That's going to be 1/2 minus 8/2, which will be -7/2. So my first number is -7/2. I got that one from plugging in k equals -1. The next integer up would be k equals 0. Well, that's pretty easy to do in my head. If you plug in 0, all you're going to have is 1/2. And then if you plug in 1, that would be the next one. That would be 1/2 plus 4. That's basically the same thing we did over here, just with a plus. So that's obviously going to end up being 9/2. And then the next one, k would be 2. So 1/2 plus 8 now. In other words, 8.5. 8.5 as an improper would be 17/2. I think all that's happening here is I'm adding 4 every time. So I had -3.5, plus 4 would be 1/2, plus 4 would be 4.5, and then 8.5, and then the next one is going to be 12.5. 12.5 would be 25/2. And then the third example, k is now an integer greater than or equal to 0. So we're going to start at 0 and count up from there. Obviously, if I plug 0 into this, I'm just going to have the pi over 4. Let's see, then I would plug in 1, so I would have pi over 4 plus pi over 2. When I get the common denominator, Pi over 2, multiply top and bottom by 2. That'll turn that into 2 pi over 4. So I'll have pi over 4 plus 2 pi over 4, which is obviously 3 pi over 4. The next one would be k equals 2. Let's see, it looks like if I were to plug a 2 in for this k, it's just going to wipe out that 2 on the bottom. So I'd end up with pi over 4 plus pi. Again, I would need a common denominator, so I'd have to turn this into 4 pi over 4. Pi over 4 plus 4 pi over 4 would be 5 pi over 4. I think you can start to see the pattern here. 1 pi over 4, 3 pi over 4, 5 pi over 4. It's obviously going to go to 7 pi over 4, and then 9 pi over 4 for the final one. And then finally, number 11, we just want a quick review of the sine function. We want one complete period and sufficient scale for the 5 key points. The basic sine function, of course, is just the hill and the valley. It ends out here at 2 pi. The middle spot would be pi. The first tick mark takes place at pi over 2. The third tick mark would be 3 pi over 2. The top is 1 and the bottom is negative 1. And I think we've done what is asked. One complete period with all the scale showing.